The National Electrical Code, or NEC, doesn't actually define the term low voltage. You will not find a specific section within the NEC that provides a universal definition for what constitutes low voltage. The NEC addresses voltage levels in different contexts, and the applicable requirements vary depending on the voltage. UL 1838, which is a standard specifically for low voltage landscape lighting systems, does have a definition within its scope. This standard covers the safety requirements for light fixtures and accessories intended for landscape applications, and it includes floodlights, lanterns, lamp holders, luminaires, and post lights. The scope of UL 1838 specifies that luminaires and accessories are designed to operate with a maximum output voltage of 15 volts root mean square, or RMS, or 20 volts peak. It's important to understand the difference between RMS and peak voltage. RMS voltage is the statistical measure of the magnitude of a varying voltage. It is the effective voltage that produces the same heating effect as a direct current voltage of the same value. Peak voltage is the maximum instantaneous voltage value that a waveform reaches. For a sinusoidal waveform, the peak voltage is higher than the RMS voltage. The relationship between peak and RMS voltage for a sine wave is peak voltage equals RMS voltage times the square root of 2, which is approximately 1.414. Therefore, a 15 volts RMS sine wave would have a peak voltage of approximately 21.21 volts. Since UL 1838 specifies a maximum peak voltage of 20 volts, this implies that the standard is considering waveforms that may not be purely sinusoidal, or that it is providing a margin of safety. Now let's delve deeper into why this distinction is important and how it affects practical applications. Firstly, the absence of a universal low voltage definition in the NEC means that different articles and sections of the code may use the term low voltage in different contexts, each with its own specific voltage thresholds and requirements. For example, Article 411 in the NEC, which covers lighting systems operating at 30 volts or less, has specific requirements for the installation and use of these systems. This article might be relevant to some low-voltage landscape lighting installations, but it's essential to note that it applies specifically to systems operating at 30 volts or less and has its own set of rules. Secondly, the UL 1838 standard focuses specifically on the safety of low-voltage landscape lighting systems. It sets requirements for the construction, performance, and marking of these systems to ensure that they are safe for use in outdoor environments. The 15 volts RMS or 20 volts peak limitation is intended to reduce the risk of electric shock and other hazards associated with higher voltage systems. Thirdly, when selecting and installing low-voltage landscape lighting systems, it's crucial to comply with both the NEC and the UL 1838 standard as applicable. The NEC provides general requirements for electrical installations, while UL 1838 provides specific requirements for low-voltage landscape lighting systems. In many cases, local codes and regulations will also reference or adopt these standards, so it's important to check with your local authorities to ensure compliance. Fourthly, the disconnect you perceive between the NEC and UL 1838 arises from the fact that the NEC doesn't offer a singular definition of low voltage, whereas UL 1838 defines it within its limited scope. The NEC is a comprehensive code that covers all aspects of electrical installations, while UL 1838 is a product safety standard that focuses on a specific type of equipment. Fifthly, let's discuss some practical implications of these voltage limitations. The 15 volts RMS or 20 volts peak limitation in UL 1838 means the transformers used in low voltage landscape lighting systems must be designed to output voltage within these limits. This is to ensure that the system operates safely and reduces the risk of electric shock. It also affects the design of the lighting fixtures and accessories, as they must be compatible with these voltage levels. Sixthly, it is important to use the correct type of wire in landscape lighting. Since the wire is outside and can be exposed to the elements, it must be rated for wet locations. Furthermore, low-voltage landscape lighting often uses a larger gauge wire than line-voltage lighting to minimize voltage drop over longer distances. Voltage drop occurs when the voltage at the end of a wire is lower than the voltage at the beginning due to the resistance of the wire. Excessive voltage drop can cause lights to be dimmer than expected or not to function properly. To mitigate voltage drop, it is important to select the appropriate wire gauge for the length of the run and the current draw of the lights. Consult voltage drop tables to determine the correct wire size. Seventhly, the selection of low voltage transformers is critical for a safe and efficient landscape lighting system. Transformers must be properly rated for the total wattage of the lights they are powering. Overloading a transformer can cause it to overheat and fail, which can create a fire hazard. It is also important to choose a transformer that is designed for outdoor use and is protected from the elements. Transformers should be installed in a well-ventilated area to prevent overheating. Eighthly, proper grounding is also essential for safety. The grounding conductor provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or ground fault circuit interrupter, or GFCI, and to energize the circuit in the event of a fault. This reduces the risk of electric shock. All metal parts of the landscape lighting system, including the transformer enclosure and light fixtures, should be properly grounded. Ninthly, ground fault circuit interrupters, or GFCIs, are an important safety device that can help to protect people from electric shock. A GFCI is a device that monitors the current flowing in a circuit and trips the circuit breaker if it detects a ground fault. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. Tenthly, regular maintenance of landscape lighting systems is essential for ensuring their safety and performance. This includes inspecting the wiring, connections, and fixtures for damage or corrosion. Damaged or corroded components should be replaced immediately. It is also important to trim vegetation around the lights to prevent it from blocking the light or damaging the fixtures. Furthermore, it is important to check the voltage of the lights periodically to ensure that they are operating within the proper voltage range. If the voltage is too low, it may be necessary to adjust the transformer tap or replace the wiring with a larger gauge wire. To reiterate the critical points, firstly, the NEC does not provide a universal definition of low voltage. Secondly, UL 1838 defines low voltage for landscape lighting as a maximum output of 15 volts RMS or 20 volts peak. Thirdly, when installing landscape lighting, comply with both NEC and UL 1838, as well as local codes. Fourthly, use appropriate wire gauge for wet locations and minimize voltage drop. Fifthly, select correctly rated and outdoor suitable transformers. Sixthly, ensure proper grounding for all metal parts. Seventhly, employ GFCIs for shock protection in wet locations. Eighthly, perform regular maintenance including inspection and voltage checks. And finally, while the NEC does not define low voltage in a general sense, other articles within the NEC address specific voltage thresholds and requirements. For example, Article 411 covers lighting systems operating at 30 volts or less, and it provides specific rules for these systems. The specific requirements in Article 411 include limitations on the types of lighting fixtures that can be used, the methods of wiring, and the need for overcurrent protection. Another example is Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. These circuits operate at different voltage and power levels, and each class has its own set of requirements. The NEC also addresses low voltage in the context of specific applications, such as fire alarm systems, communication systems, and data processing systems. Each of these applications has its own set of requirements related to voltage, wiring, and protection. In summary, while the NEC does not offer a single definition of low voltage, it addresses voltage levels in various contexts, and the specific requirements depend on the application and voltage level. UL 1838 defines low voltage specifically for landscape lighting, focusing on safety within the context. Compliance with both the NEC and applicable product safety standards, like UL 1838, along with local codes, is essential for ensuring the safety and proper functioning of electrical systems. When dealing with electrical systems, Always prioritize safety and consult with qualified professionals if you have any questions or concerns. Always consult the latest edition of the NEC and the relevant UL standards for the most up-to-date information and requirements. Remember that electrical codes and standards are constantly evolving, so it's important to stay informed about the latest changes. When working with electrical systems, it is essential to follow all safety precautions and to wear appropriate personal protective equipment, or PPE, such as gloves and eye protection. Never work on electrical systems unless you are qualified to do so. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. When planning a landscape lighting project, start by creating a detailed design that includes the location of the lights, the type of fixtures, and the wiring layout. Be sure to consider the aesthetics of the design as well as the functionality. Once you have a design, you can start to select the appropriate materials and equipment. Choose high-quality fixtures and wiring that are designed for outdoor use. Also, select a transformer that is properly rated for the total wattage of the lights. Before starting the installation, be sure to obtain any necessary permits from your local authorities. Permits are often required for electrical work, and it is important to comply with all local codes and regulations. When installing the wiring, be sure to follow all NEC requirements. Use the proper wiring methods and make sure that all connections are secure. Also, be sure to properly ground all metal parts of the system. After the installation is complete, test the system to ensure that it is functioning properly. Check the voltage at the lights to make sure that they are operating within the proper voltage range. Also, check for any ground faults. If you find any problems, correct them immediately. Finally, be sure to maintain the system regularly. Inspect the wiring, connections, and fixtures for damage or corrosion. Replace any damaged or corroded components immediately. Also, trim vegetation around the lights to prevent it from blocking the light or damaging the fixtures. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Electrical codes and standards are complex and can vary depending on the location. Always consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes and regulations. When working with electrical systems, always be aware of the potential hazards and take appropriate precautions to protect yourself from electric shock and other injuries. Electricity can be dangerous, so it is important to treat it with respect. Remember to always turn off the power before working on any electrical system. Use a voltage tester to verify that the power is off before you begin working. Never work on electrical systems in wet conditions. If you have any doubts about your ability to safely work on an electrical system, hire a qualified electrician.